Welcome everybody. My name is Emma and I'm the Marketing Manager for CENTIEL UK, and today I'm going to be your host and moderator. And I'm joined by two of my colleagues, Loise McGarry, Sales and Marketing Director, and Aaron Oddy, Sales Engineer. Just before we start, gents, would you be able to do me a quick introduction? So Louis, quick 30 seconds at the most.
Yeah, hi there. I'm, as Emma said, Loise McGarry, Sales and Marketing Director for CENTIEL UK. I've been working with the company since we became live in the UK, and I've got approximately 15 years in the UPS industry.
That's great. Aaron?
Oh yeah, as Emma said, I'm Aaron Oddy. I'm Sales Engineer at CENTIEL UK. I've only been here sort of about a year now. I joined last March, and I've been in the industry about 5 years.
That's great, thanks both. So for anybody on the audience today that may not know the history of CENTIEL, I'd just like Lou to do a very brief introduction of the company and the heritage, if that's okay.
Yeah, no problem. Thank you, Emma. Warm welcome to everyone this afternoon. So CENTIEL UK are a subsidiary of a Swiss-based technical innovations company who predominantly manufacture UPSs. So these guys were, as CENTIEL, were established in 2015. They're a global company with approximately, well, in excess of 50 partners now. But the heritage of the company goes back quite a long way. I mean, the same design team were responsible for the first transformer-less UPS. I don't know if any of you remember the old legacy equipment. We don't really talk about them much anymore, but the big transformers that we used to step up the voltages, which were then very quickly replaced by very clever DC electronics, IGBTs, to take away that big hunk of metal, reduce footprints, keep things very, very highly efficient. So these guys were the first to produce a true transformers UPS into the market, but more unique to them, where they were responsible for the first true modular UPS system. So they went on very quickly after that, and this was approximately early 2000s to develop the second generation, third generation, and now CENTIEL SA Switzerland are responsible for the fourth generation true modular UPS. So when I say true modular UPS, we're talking about a differentiator called DARA.
Okay. So clearly there's some history there with CENTIEL, but can you tell me about DARA? What actually is DARA?
Yeah, so DARA is basically a distributed active redundant architecture. That's what the acronym stands for. Okay. So to explain it, it's best to go through each stage at a time. So the first part of it is the D stands for distributed. So the philosophy behind the distribution of the system is to replicate every single component within the UPS. And when we say in the UPS, we talk about UPS modules, multiple modules within the system to make up a total UPS. So every module has a static inverter, for the static bypass switch, a rectifier, a CPU system, control logic, interrogation panel, physical control wiring, so on and so forth. And the reason behind this is to remove any single point of failure within the system. Effectively, a UPS module is a UPS in its own right. You can take it out of the actual UPS system, cable it up, and it will behave as a standard UPS. So it's not just the physical side of things. It's we use another acronym called Intelligent Module Technology. And if you can move on a slide. This brings us, thank you, Emma, this brings us into something called active, which is the second part of the acronym. So the active part is about the brain function, the communication within the actual system. So the modules don't physically just distribute all their physical components. The control logic within inside the system is thus everything is talking at all times to each other. Yes, of course, there is a leader and a follower type system involved here, where one person tells the other person what to do. But if that person becomes unwell, a little bit like the pandemic we're living in at the moment, if that person becomes unwell, it's told to isolate from the system and not interact with the rest. So it then passes on that bit of information or assigns that leader function to someone else. So very simple term here. What we can do with control logic is we can assign who is the leader, we can assign how the load is shared equally among modules, and we can also isolate automatically any issue within the system, whether that's actually a fault or actually down to maintenance. So the purpose of this is to make sure that the critical load is protected at all times. So the next part is redundant. I think a video will play very shortly on this. So this video represents one of our engineers. It's actually a sped up version, but the most important part here is not just about having enough UPS to support the load and an additional UPS to create the redundant member or the resilience level. It's about the availability of the system. And to create availability, we need to design a system that can be flexible to a point where we can safely and hot live on a system swap a module. So the days are sort of gone where you have a monolithic block UPS where there's a fault on site and an engineer is called and he has to take apart the UPS and diagnose what the problem is. We now simply turn up to site, exchange a module while the rest of the system is running and supporting the load, access the service module, put it into the system, self-diagnoses, self-balances with the active control logic, and the system is back up to normal, back up to resilience. But it's not just having the resilience, it's about how fast that system can be maintained and put back into service, or back up to resilience in +1 and +2. So that then calls for a system that not is only flexible, but also has complete zero downtime. So the final part of this is the physical architecture. So being able to have this technology where you can hot swap and do it safely, have a control logic where it's self-loading, self-sharing, self-diagnosing, means that we can then physically scale the system no longer this way, which is a horizontal approach, but more of a vertical concept where we can stack upwards first, and then we can grow outwards. So as we know, space is a premium. We can create very high, resilient, available systems in a very, very small footprint. It also enables us to create some sort of future-proofing with a pay-as-you-grow function, and it also allows us to reduce overall footprints and create some sort of total cost of ownership with a pay-as-you-grow flexibility.
Okay, that was great. Do you want to do a quick wrap up of what you're looking for?
So a bit of a summary as to this wonderful word DART, this acronym. So what we're trying to produce is not only the most efficient, easy to live with, zero downtime and high efficient system. Today's world is all about availability. Creating that zero downtime, the speed of repair is at the utmost, and it's not just in banking and finance. We see a lot in hospitals. We've done a lot of healthcare over the last year, particularly within the latest state of the world. So everything has to be available all of the time, and that's why DART exists, and that's our differentiator within modular technology.
That's great, thanks. Very well explained.
Thank you very much.
Yeah. So what I'd like to actually do now is I'd actually like to just ask Aaron a couple of questions. So Aaron, you come from a completely different industry to this. Actually, before I start, well, congratulations on your 1-year anniversary with the team. Interesting year, yeah?
Yeah, it really has. Thank you. Yeah, it's been a really interesting year. Started with CENTIEL a year ago, earlier this week. Started at the start of lockdown in 2020, and it's just probably not been the way I wanted to start in terms of being in lockdown and not having the opportunity to go out and have the normality really taken away. But it's given me an opportunity to work on some really interesting projects over the last year.
Ooh, good. Well, we're glad to have you. It's been a good year. So welcome officially 1 year in. So That's death by fire as to call it. Let's check in here for this. So joining the team, obviously coming from an industrial background, it's obviously completely different. So I'm kind of interested in getting your take on the products and how Essentials technology supports projects in more of the industrial arena.
Yeah, of course. So just let everyone know, previously I was with a company who was still in the UPS industry, but more into the industrial side and looking at sort of more robust systems and sort of higher IP rating. So typically a UPS within a data center or a comms room is generally IP20 rating, just due to the clean environment, well air conditioned and at the right temperatures. These are sort of more commercial UPS systems within the industry, rather than the more robust high ingress protected designs that are sort of made to order, really, and made to certain projects, which is needed for harsher environments. The more robust the equipment, essentially the longer it will last in harsher environments, as long as it's designed correctly. Considerations to environmental impacts onto a UPS during design stage can actually allow for solutions to be included, such as forced air to prevent any UPS sucking in dust, or bringing in something that's not within the room that can actually damage internal components and not have the UPS working in its correct way. Designing your equipment at the start for the environment is always going to be the more cost-effective solution in the long run. And it will literally protect your UPS from any potential failures resulting in your critical load being protected at all times, which is what UPS is there for, and as having that additional support and always having that backup. And like I say, being Essential and seeing all the technology that's available and availability of our UPS systems, combining Essential's technology and having that pay-as-you-grow capability within an IP-rated enclosure that can be done, having that scalability as well is superb in terms of having your critical load protected at the highest possible level. But then you can go on to having your total cost of ownership looked at, and the scalability of, say, having the first module there, but also being able to scale it up from 10 to 20 or to 40 kilowatt, and as you grow, you're paying to have that support as well there, and it's just building systems that are already in place within the infrastructure. And that's just the beauty behind modular, and having our system where it's a universal rack as well. And it's, like I say, from what Louis just touched on, is pulling the modules out, having that mean time to repair, and having the modules hot swappable is superb.
Okay, cheers, Aaron. It's funny, actually, I was in a conversation with David Bond the other week about airflow, and you know, clearly it's a what's it topic, but he was talking about data center design and how there's a well-known data center where they actually use the forced air to bring in outside air from a really low temperature into the data center to produce cooling, which obviously helps saving on aircon costs. And so I thought that was quite an interesting thing. It's quite clever, really.
Yeah, I agree. To be honest, it's really clever, and it's just got to be done in the correct way. The design of any plant room or data center is really important. A clever way is that UPS and any associated equipment can allow you to sort of control the air conditioning if you actually separate the rooms or have a partition in between, say, the UPS and the batteries, and have that internal wall to separate the equipment. So this means only housing potentially the batteries that are going to need environmental consideration. Generally, most UPSs and non-modular UPSs are operational between 0 and 40 degrees, but by removing sort of all other heat sources, such as the UPS from the batteries, means they're now sitting in an ambient temperature anyway, which is on average between 20 and 22 degrees C. So like I said, this could remove the need for air conditioning altogether, resulting in huge costs going forward as well. As we probably all know, air conditioning and the running cost of that, having always trying to keep the room at optimum temperature and dependent on the size of that room, the footprint is quite massive. And by keeping the batteries at your optimum temperature, like I said before, 20 to 22 degrees C, it's prolonging that life, and the replacement costs are just at a lower level to minimise too as well for the labour.
Okay, so it's quite important, really, when you're doing your design, going through the client design of a room and the layout to make sure that the UPS is in the right position. You consider things like airflow and cooling, and you can make these kind of clever decisions to help with the client's kind of life cycle of their product. So that's great, thank you. So we've obviously got quite a little bit of time left, so I'm actually going to put Louis back into the hot seat, if that's okay. I'm sure you're gonna love it. Now we were talking about DORA and obviously the technology that we've got, and we talked about modular, but there isn't modular isn't just the only kind of UPS that's out there within our product range, and I know standalone does have its place in the market, but our standalone solution, it comes from the same technology that goes into the modular technology, the whole system. So why do we do that, and how does that benefit our customers really?
Yeah, that's well, it's a commercial question and a design question in the same context really. So we have to be seen to be producing a monolithic block, or what we call standalone UPS, non-modular system. There are areas to fulfill, and it's generally driven by design and cost. So we have to have a product which fits a certain part of the market. There are still calls for standalone technology. It still exists. It's still very good. It's still very robust. The way that we design standalone technology is on a similar context to modular, in that there is only a single rectifier, inverter, and state switch and CPU as a block, but the way in which that system can be serviced, everything is front accessible now. Everything is on sub-component level, so you're not at minor component level. So, for example, an array of capacitors can be replaced as a complete sub-assembly, as opposed to individual components being sold. And that again, so we're still trying to push the envelope on the most available system when it comes to downtime, even in the monolithic block standalone technology market. We tend to push modular UPSs a lot more because it's been so successful over the last 20 years, because it has so many benefits to the customer. It's sort of almost worth, getting hold of the premium product that's going to help you in the future. You're going to be able to be way more flexible with your growth pattern, with your, with your serviceability, with your actual, you're living with the system for the next 10 to 15 years. Let's make it as efficient as possible. So, yes, so the answer to the question is, we still have to fulfill a gap in the market. We do standalone UPSs, and they are of the highest quality, the highest efficiency, but still trying to make them still the most available standalone UPSs that are in the market.
Nice. So I was actually, I'll just do a time check, yeah. I was actually talking with Gerardo earlier this week, funnily enough, and he was talking to me about the different types of architecture. Now, obviously, I'm not from the UPS background. I've only been about 4 years, I think, in the UPS industry, and I do not have an engineering bone in my body. But he was talking about how standalone was almost the original of the architectures and development that's gone over the years, where you get standalone, and then there's standalone with a modular element, but it's not a hot swappable modular. Yeah. And although they have the place, there is the risk of single points of failure, because although you can add redundancy by popping another parallel system, basically, you always at some point have to go to maintenance bypass. So forgive me if I say anything that isn't engineering here, but you always have to go to maintenance bypass to do any of if there's a fault or a service you need for it. So you're automatically almost adding risk into your system, which is why the modular hot swappable technology and safe hot swappable is key. So is there any kind of comments on there where you can talk a little bit more technical for me on it, please?
I mean, over the years, we see a lot more inquiry for modular. We're designing a lot more, consistently around modular. You're absolutely right. Modular is a definition. I mean, you could call modular putting 5 monolithic 100 kVAs together in parallel across the floor with a load of switch kit. Effectively, that is modular. But we're sort of, this is why we have to use an acronym like DARA, a differentiator that says this is what true modular means. Traditionally, to be able to create some sort of resilience, N+1 or 2N+1 or whatever, you'd have to parallel the physical UPSs together, and there would be some sort of bypass facility. To be able to do any maintenance on those UPSs, you would have to go to external maintenance bypass, putting the load a risk level on raw mains to be able to achieve that maintenance. Whereas modular now, we don't have to do any switching of the load into a critical state. It can all be done live. So it's not just about the terminology of modular. What does modular mean? It's about what does true modular mean? What does safe hot swap mean? What does maintainability mean? What does this flexibility mean? It's much bigger than just that could be modular because we can build it. It's all of it together, which is why we use this terminology DARA, which means we can produce a true modular. Not a term I like using a lot, but solution. It's a solution.
Okay, perfect. So one of the key words I picked up there as well was flexibility. So with the product itself, if you're talking about, obviously we're back onto the modular side of it. With modular, the reason I think the flexibility is quite key is because you can actually put it into all sorts of applications. So some of the projects that Aaron was talking about earlier with the IP ratings, the ingress protection ratings, you're talking about an enclosure that's protected from dust, water and harsh environments, and you can then slot in that universal rack solution of the modular into that box. You've got the highest performing UPS possible, highest availability, efficiencies. You can scale it up, scale it down. You've got the ones that just slot straight into a server rack that can go into that enclosure, and you've got a combination of industrial and commercial all together. And you can apply that into many different scenarios. So take that visual base function and take it into a comms room, pop it into your server rack. Sorry, I'm doing the hands thing as well. I'm very aware of it. And then you can do the same in other locations. So you can scale it into much bigger frames. Yeah. I know that we have partners across the globe where we do very bespoke creations for them. I think it was somewhere in Australia. We got a particularly large system. It's 3 systems with the batteries built into this huge container. So the bespoke element is something that we offer globally, obviously, and in the UK we can do to sales for different projects. Is there any projects that you've got that you've possibly been working on recently, without naming clients and any confidentiality, but anything interesting we can tell our audience for the last 8 minutes?
Yeah, so this whole idea of is it a niche product for a niche particular segment of the market? Well, no, it's not. I mean, it can literally be built into anything. We find we do a lot of life cycle replacements on kit, and historically systems have been designed to accommodate what could be tomorrow. So we see a lot of oversized systems that have been in place and been in place for quite some years. And that enables us to approach a client to look to replace the equipment, but we're able to put in the infrastructure that matches the physical rating of that equipment. But when we replace it, we only replace it with what they actually need to run the load and create the resilience. So their replacement costs become less. Okay, so that sort of ticks that box. It's not just having, like, let's say someone in the finance or the banking world having a UPS that has a small footprint, really efficient, right size. It doesn't want our engineers on site for prolonged amounts of time anymore. It's literally we turn up to site, we exchange a module, we do a very efficient service on that bit of equipment. But it also lends itself to either, maybe an offshore island application or remote parts of the country. It could be, when it comes to like IP rated or semi-industrial solutions, power stations where access is difficult, where you can exchange, first level response, the client can exchange modules themselves. And any problems, they get shipped back to HQ or even Switzerland for verification, restamp and send back. So it's not just about putting the right system in place. It's also about giving the client something that enables them to carry on maintaining the system, even when the location doesn't allow the system to be maintained.
Interesting. So in theory, if you were in a really remote location, you could have a spare module. So you've got your N+1. You've then got a potential spare module, like a maintenance module. Would you class it as? Yeah. The maintenance module, that if there is an issue, you can pop your maintenance module in, pop out your potentially faulty module, you've still got your redundancy, you're still fully protected, and all it's taken is, what, as quick as Sid does it on a video there.
Correct, yeah.
About 3.5 minutes now.
Yeah, I mean, you're absolutely right. I mean, the truth is these systems are very, very, very fast. Most of the maintenance that happens on them isn't because of downtime with the module. It would be more to do with something like a fan or capacitor replacement, and even technology has moved on with those components now, where a client may be told that those components need to be replaced in 4 or 5 years. Actually, our DC side of things are 10 years now on capacitors, and the AC caps are 6. So, actual real maintenance on these bits of kits due to error is rare, but preventative maintenance is absolutely important. Absolutely important.
Okay, great. So we do have around about 5 minutes left. Now, so far we don't have any questions from the audience, so I'm going to use it to probably put Aaron back in the hot seat. Sorry, Aaron. I'm going to get the most out of you now. I've got the pair of you available. So just because it's a bit of a hot topic with some of our partners at the moment, and the uptake on pre-sales has been fantastic across the globe, lithium is massively back on the agenda. Now, I'm aware you've been working on a project. Again, don't give me too many details that are going to cause you problems for your projects and your clients, but how have you found the lithium product? Is there anything particularly interesting you can share with us? Is it much different?
Yeah, of course. Well, to be honest, the general battery that are used across the market, as probably everyone knows, is VRLA. Comparing lithium to that is there's some massive pluses, and it's normally required for very certain and specific projects where it's needed to fit into a really compact space. It's, to be honest, if you were to do a general rule of thumb, it's normally half the size of a VRLA battery.
Oh, wow.
If you're comparing them. So, yeah, having that, and it's also a lot lighter as well. So if you're having the batteries being populated on a 5th floor, 6th floor, or even on the roof, it's a massive plus having that battery and the weight there that's involved in. It's a brilliant bit of kit that's sort of coming through into the market, and it's only ever growing and getting bigger, I think. The only sort of down point from it is the initial cost, but it's there. It's a longer term battery as well, compared to being sort of 15, 20 years on it as well, and maintaining it can work in high temperatures. So it's a brilliant sort of product that is coming to market, and it's been around for a long time, and I'm sure it's only going to get bigger.
Okay, great.
That's a good point on the cost side. Have I got time to
you do have a couple. It's come down there, hasn't it?
So, the costing is fantastic. So initially, when the lithium product hit the UPS market, the cost was, we were seeing 4 or 5 times more than VRLA banks. So the benefits of its size, footprint, weight, density wasn't enough to outweigh the cost of it. The initial R&D costs are now sort of slowly disappearing. We have a very, very good product, and rather than it being 4 or 5 times now, it's closer to maybe only twice as much. But the benefits are now starting to outweigh, the cost and the benefits with that. So the inquiry level is going up. The amount of projects we're working on with it, actually physically installing it, is increasing, and it's a very, very fine-tuned product now. And I think it will just go from strength to strength, and just look how many lithium-ion battery cars on the road now. So yeah, it's certainly something we're going to be talking about a lot over the next 12 months.
So I want to very quickly just touch on the point that Aaron made about the weight and how lightweight it is. Now, obviously I get to go to sites and do occasional kind of case study type opportunities. So we recently did some work where we are putting a lot of things on roofs in locations where they can't expand outwards, as you were saying earlier, they're having to go up. It's the same not just for UPSs, it's the same for actual infrastructure, real estate. So you're going up and you're popping things onto tops of roofs with these kind of modular type plant rooms.
Yeah,
is that the right word? Yeah, like GRP, there you go. So in a situation like that, when you're already adding a heavy kind of box to the top of a roof, and you're possibly having to put some reinforced steel works there, a lithium solution is probably ideal for that, because it's not going to add so much weight as the VRLA.
Yeah,
Yeah, completely. It reduces the weight there. It's also the size of the GLP as well. If you're reducing the footprint and also reducing the weight, potentially reducing the size of the GLP that has to go on a roof or a bespoke purpose-built enclosure, even if that's a container or a GLP. So there's plenty of pluses to it.
I know we're sort of getting on the bandwagon with lithium-ion now, and it's a great subject to talk about. And in that very reason for being on the roof as well, lithium has the ability to work in a different range of temperature. So the real niche sweet spot for the RLA, which is about 22 degrees, real niche spot. It's not saying the battery's going to collapse if it's outside that bracket, but you are affecting its life. Whereas lithium ion's bracket is way bigger, so it allows you to put it into environments which may be slightly warmer or fluctuate. I mean, roofs are a perfect thing, winter and summer. Seeing something on a roof that's likely to bake in a tin can. So it's adding to our flexibility of our systems.
Okay, that's great. So I'm very conscious that we're around about time now. So I'd like to thank you both for joining, and obviously for your input and for taking some of my not planned questions and putting you under pressure. But so it's all good. So thank you ever so much for turning up today, and hopefully we'll do a few more of these. And thank you for everybody who's dialed in for the call. This will be available on a video afterwards. So any questions that you may have following this, then please feel free when we post the video onto LinkedIn to just add your questions to the LinkedIn comments, and we'll be able to come back to you directly. Thanks ever so much for joining, and see you later.
Thank you.
Bye. Bye.
Cheers.
Bye-bye.